Hello. I think I am live now. I will wait for a minute or so and then we will get started. Can anyone confirm if audio and everything is fine? And to answer the question in the chat, I did not stream the last Code Forces round, which was 933. And like, how was your context? Like, I was the first person to solve Manhattan's OR, but I could not get operating on A until the very last. So I would pretty much discuss these 6 problems. So like audio and everything is fine, right? Before I get started. Okay, thanks Vasif. I will get started. I will first start from the 3 problems which are not rated in the D1. He reached the maximum speed of s km per hour. As per the rules of government, the speed of vehicle must not exceed 40 km per hour. Otherwise, the person will be fined. You need to tell whether Alice will be fined or not. And the input format says the only line of input contains a single integer s, denoting the maximal speed Alice reached while driving. So it's again an if else problem where if s is does not exist 40, then we should print yes, otherwise we should print no. So if s is less than equal to 40, the answer is no, otherwise the answer is yes. And the code will pretty much look like int n, c in n, and if n is less than equal to 40, print no, otherwise print yes. And pretty much that was the problem. I will move to second problem as well. Like second problem says School of Safland uses 50-50 rule to grade their student. As per the rule, students are awarded Z-graph if attendance is strictly less than 50%, F grade if the score is strictly less than 50% marks given that their attendance is greater than equal to 50%, and A grade otherwise. You are given two integers x and y denoting the percentage of attendance and the percentage of marks obtained by Alice. What grade will Alice get? It was again an if else problem where like earlier there was only one line input, now we also have a number of test cases as input. So we first take number of test cases as input and we run a loop which runs t times, and each time we take two integers as input x and y, and z grade is awarded if x is less than 50, which is attendance is strictly less than 50. And once we reach here, like we definitely know that x is at least greater than equal to 50%. So like now we can ignore this part and like we have to check if the score is less than 50% marks or not. And here it would be like if the score is less than 50, then Alice would get 50 F grade, otherwise Alice would get A grade. And this was pretty much the idea for this problem. Any questions on the first 2 problems, like before we move to the next one? Okay, next problem says fake certificate. You are given a binary string S of length n representing the attendance seat of Alice. For the days when Alice went to school, SI is 1, otherwise SI equal to 0. Alice wants to increase her attendance. She can perform the following operation at most. Choose any substring of S where Alice was absent every day. She can then give a medical certificate for this period and will be marked present for the whole period. Note that the substring is a continuous segment of a string. For example, ACAB is a substring of ABACAB, where ACAB appears here. But AA and D are not a substring. In other words, like it should be the continuous segment. You need to find the maximum number of days Alice will be marked present after performing the operation at most once. Like let's look at the samples ones. So in the first sample, Alice was present every day. No fake certificate or anything is required, and the answer is 3. In the second sample, Alice was absent every day. So she can give a certificate for all the 3 days, and the answer will be 3. In the third sample, like Alice was present on 2 days, and like the number of ways she can give the certificate is either on this day, in which case like there would be 3%, or these two together. In this case, like she would be present for all the 4 days, or this one, in that case also she would be present for the 3 days. So the answer is 4 here. And similarly, going to the next sample, the next one is like again like the similar example. It says that one extra zero is there, 0, 0, 1, 0, 0, 1. In this case, if Alice gives fake certificate for these 2 days, then also total 4 days would be there. Or she can also choose these 4, and these 2 and 4 continuous days would be present. So overall, the answer is number of days Alice is present plus number of continuous absence. Maximum number of continuous absence. So we can count the number of days present by counting the number of ones. And to count the maximum number of continuous absent, we can either run a for loop, or we can look at all the places where Alice is present and take the difference between them. And both of them will work over here. So what I did was I maintained a variable which I increment whenever Alice is absent. And whenever Alice is present, I assign that counter to 0. And I looked at like the maximum value of that counter I had. So number of test cases as input, testing as input, and this is the maximum continuous day Alice is absent. Like let's call it present. Number of days Alice is present. So like when I am running a for loop, whenever Alice is present, I increment the counter for present by 1, and previous absent, like previous continuous absent, should be marked as 0. And if Alice is absent, then previous absent, like the number of days increases by 1. And like this was pretty much the idea for this problem. Any questions on this one before we move to the next problem? Next problem was binary minimal. Alice is given a binary string s of length n. She can perform the following operations on it. Select an index I and delete the character si. Select an index I and flip the character si. Note that flipping 1 becomes 0 and vice versa. Find the lexicographically smallest string Alice can obtain using at most k operations. Note that the string s is said to be lexicographically smaller than y if s is a prefix of y, or the smallest index I where x and y differs and xi is less than yi. So like there are multiple parts to this problem. Like the samples aren't much helpful, although they give some. Like if you can do one operation, then like if you have 3 zeros, then you can delete one character to get one operation. But if you flip one, then like you can try out all the operations. Like let's say we have some sample string with us. And what happens like if we can apply only one operation? You can try out like if you delete this character, then this one moves forward, and like the other string would start with 1. So like that's definitely more than the current string we have. Similarly, if you change this, you can either change the first one to 0 and the remaining string would be 0 1 1 0 1 0 1. Or the other choice you have is you can also delete this character. In this case, the final string would become 0 1 1 0 1 0 1. And you can notice that it's whenever we delete something, the remaining ones after here move one step forward. And like if you try to look at the lexicographically smaller strings, like if you have some string like this, and let's assume that there is some 1 over here. Like probably let's say like here if you insert a 0, this is S1, S2, S3, S4, S5, S6, S7, S8, S9, S10. Let's say there is some 1 here. Then your new string becomes S1, S2, S3, S4, S5, 0, S6, S7, S8, S9, S10. Then at whatever place the 1 was, the first one, it will move one step backward. And you can verify that this string is lexicographically smaller than the original string. For example, let's say a 1 is here. The first one is here, so like this is 0. Then your final string, and like this string is smaller than this string. Because here the first time 1 appears, you are pushing it backward once. And similarly, you can try to look at it like best case, like you either have two choices. You don't delete if the final string there at least 1 remains. If number of ones are greater than k, and because you can delete only at max k characters, there would be at least some ones will remain over there. So that's why the best scenario in this case would be to find first k ones and change them to 0. And the other case when the number of ones initially is less than k. Then we can first all ones. Then with remaining operation we can delete the extra 0. So like if there are n characters initially, at last you will have n minus k characters. And all of them would be 0. And like these were essentially like the solution. Like if count the number of ones in the original string, if the number of ones is less than k, then you would be able to delete k characters and you will be left with n minus k zeros in the final string. Otherwise, because at least some ones will remain even if you delete some of the characters. So you should try to change the initial occurrences of 1 to 0 to get the lexicographically as small as string possible. This was the idea, like read n and k, read the string, count the number of ones, a for loop, or like if you prefer something else, then you can also do If the number of ones is less than k, then and at last you would be left with n minus k zeros, so you should print them. Otherwise, you should change all the first k occurrences of zeros, of first k occurrences of ones to zeros. So iterate on the string. If the current character is 0, we don't have to do anything. If we have exhausted all operations, we can't do anything. Otherwise, we change the current 1 to 0 and also decrease the number of remaining operations by 1. And whatever the string was, we print it at the end. And like this is the idea. So any questions on this one before we move to the bucket game? Okay, moving to the next problem, bucket game. Bucket game I felt was more analyzing like what happens right now. There are n buckets where ith bucket contains AI balls initially. Alice and Bob decide to play a game with the following rules. Both players take their turns going, Alice going first. If there are no balls left, the game ends. Or in his or her turn, the player will remove a ball from any bucket which contains at least one ball. If after the move, bucket from which the ball is removed becomes empty, the player gets a point. If both players play optimally, find the player who gets more points. If both players get same points, print draw. Yeah, I gave D1. So like the game here is as follows. Like whenever someone's turn is there, pick one pile, remove a coin from it. And if this was the last coin, score increases by 1. And the question is like who has the highest score at last. So like one thing you can see is like if the current pile has 1, then whoever plays gets a point. If current pile has even number of even coins, then what person can do is like if someone like we can try to make it even coins in it. The idea is like if there are 4 coins, if someone is picking the fourth coin, then the other person should pick the third coin from it. So now 2 coins remains. Like so, like at last the pile will have only 2 coins, and whenever a person picks a coin from it, the other person can claim point. Like sorry, like if a pile contains even number of coins, and let's say if Alice picks a coin from it, then Bob should also just copy the Alice moves over here. They can keep repeating it, and let's say at last there are 2 coins in this pile. And if Bob picks a coin from this pile, then Alice can always pick it up, pick the other coin, and get a point. Or like the other way to look at it is the number of turns are finite. Like we know like if total number of coins are odd, then Alice would play the last move, and if total number of coins are even, then Bob will play the last turn. So the idea was like count the number of piles with one coin, and he, because of the greedy idea, like everyone will try to pick the pile with one coin at first, because if they don't do it, the other player can do it and get an extra point. So let's say if there are 10 piles with one, then both of them will play first 5 turn to get five points. Because let's say if Alice decided to not pick a pile with one coin and play it somewhere else, then Bob can pick the coin from that pile, and the score can probably be 6-4-6 over there. Because like if you don't pick from the pile with one coin, then other player can do it, and you may have to make an extra effort to get one more point from any other pile. And once all the piles with one coin are remaining, like if total number of piles are odd, then it's Bob's turn. Otherwise it's Alice's turn. If even in case of even, it's Alice's turn. And here the points will be equal, and here like Alice will have one extra point. And now like after removing all the piles with one coin, we can count the number of piles with odd coins and count the number of piles with even coin. And my claim pretty much was, 1 second. My claim was like either like Alice can point from all piles, or Bob can get points from all the piles. Basically, after you remove all the piles with one coin, then one of the player will get all of the coins, all of the points for all of the piles, and it will depend on like whose turn the last was. Like the idea for this was like, let's say there are 3 ones and some 11 coins here, and it's Bob's turn. Then if Bob's remove something from here, if Bob makes it 9, then Alice can make it 8 again. And if and now again we are back where the Bob's turn is there and 3 piles with odd coins are there. And now if Bob removes some number of coins from this pile, say make it 2, then Bob can change this 7 to 6 again. Like basically, if now Alice is trying to copy Bob here, if Bob's turn is there and all the piles have more than one coin, so if Alice picks a coin from a pile with even coins, then Bob can pick the coins from the same pile. And if like basically like whoever's turn is there, if they pick from a pile which contains odd coin, then the other player can also pick a pile with odd coins. And if they pick a coin from an even pile, then they can copy the coin from the same pile again. And this turn will keep going on. And at last, it would still be Bob's turn. Only one pile will be there with odd coins. and all other piles will have even coins. Now Bob can remove it from here, and after that he can start copying the Alice turn over there. And we know that if the pile has even coins, then if you keep copying the other player, then you can get the points for all the piles. And like I'm not really sure what is game DP over here. Like my claim was Alice will get odd pile plus half points. Okay, basically seal, and Bob will get pile points con. If odd for odd, then Alice gets the rest of the even pile, and else Bob like pretty much that's the idea here as well. Like once you remove all the piles which have only one coin, then if like the whoever is winning can keep try to copy the other player's move. If they pick a coin from even pile, then they also pick it from even pile. If they pick it from odd pile, they pick it from some other odd pile if it exists. And based on like you can check whoever is the last turn is there, they would be able to get all the coins. So I'm not really sure if my idea was understood by everyone. So like probably if some people have some more doubt, then I can try to show some demo games like how is the game going on right here before I jump on my code for this one. Okay. Okay. The issue with one is like whoever picks the coin gets a point for it. Like the other person does not have a opportunity to play there. Let's say these are the piles we have. And this is Alice's code, this is Bob's code. First turn is Alice. So she picks one and her score increases by one. Then it's Bob turn. She picks one, her score increases by one. Now it's Alice turn again. She picks one, her score becomes two. And the remaining piles we have is and it's Bob turn right now. And what we see is like there are three odd piles. So like we can first figure out who will play the last turn. Here the last turn like one plus one, like sum of these number is 3, 5, 5, 8, 8 plus 5, 13, 13 plus 7, 20, 3, 5, 8, 13, 20, 30, 42. Total sum is 42. So we know that the last coin will be picked up by Bob. And my claim is like Bob will get points for all of these 6 piles. 1, 2, 3. 1, 2, 3, 4, 5, 6. So Bob can get. And the idea is how will Bob get 6 turn? The way Bob can get 6 coins is like he has to ensure that the number of piles with odd number of coins is even always. So like in the Bob's turn, Bob can first change this 5 to 4. And now mirror. Now it's Alice turn. Now mirror Alice moves. pick coin. And if Alice picks coins from event pile, pick coin from same pile. And like in this case, like two coins were removed from the same file. So if you keep removing two to two, at last you will get zero. And here, like when you do it, like you will realize if it's Bob's last turn, like then Bob will always be able to find an other odd pile here. And the way here would be like, let's continue over here. 2, 3, 4, 7, 10, 12. Now if Bob removes a pile from here, it becomes 1. Alice removes a coin from here, it becomes 1. And now Bob can remove a coin from here and get 1 point. If now it's Alice's turn again, if she makes it 9, Bob should make it 8 again. If Alice makes it 7, Bob should make it 6 again. Frustrated, Alice, let's say, plays a turn here and he makes it 6 here. Then Bob should make it 2 here. Now everything is even. So wherever Alice plays, Bob will play again. So now if frustrated Alice makes it 3, Bob can make it 2 again. Frustrated Alice makes it 5, Bob can make 4 again. Now if at last if Alice is forced to make it 1, Bob can make it 0 and it's Bob point again. If Alice made it 1, Bob can make it 0 and get a point again. Like you see, like if all the piles have even number of coins, wherever the player is playing, the other player can repeat the move and get all the piles. Like we can solve by only counting odd. No one can choose even, so the answer is always depend on odd pile. Edge case is for draw. Yeah, like that can be the idea. And like how do we define the edge case here? Like let's say there are 5 piles with 1 coin. Like for example, there are 5 piles with 1 coin, and now if Bob's turn is there, then there can be a draw. No, there can't be a draw. So like that can also work, right? Like you remove all the even piles. In case of odd sum, Alice always wins. Hmm. Like I will see once. Like I can try to verify that. Yeah. If sum is odd, then Alice always wins. Like if sum is odd, then the number of 1 plus count odd is odd. This once gets divided into half and Bob has an extra edge. And like once these alls are distributed, count odd will be even. And Alice will be able to take all the moves. Yeah, this is in fact true. Like if the sum of all the coins is odd, then Alice will always win. And now the question is, what happens if the sum is odd? Sum is even. Here the possible cases are either draw, right? Like here it can be draw or Bob wins. And like the condition for draw is odd number of ones. Yes, I think this would be the case over here. So like we can ignore all the evens. Like we don't really need the count of even. This this denotes when the sum is odd. The process which I was talking about, pick odd even, can be simplified to this simple condition. Thanks. Like someone in the chat gave away the hint for it. No, this is wrong. This will ask for money, right? Like this should get a W. Yes, this gets a W. Yes, this should be the conditions. If sum is odd, Alice wins. Otherwise, if the number of piles with odd coins, this also wins. 1113, then it's a draw. Like that's right. Odd equal to 2 is also a draw, right? No, like we definitely need a count of even numbers. We can't move away with that. Like the same idea holds here. We count the number of ones. We count the number of odds. We count the number of evens. And the turn is at last odd will be distributed equally. And if there are odd number of ones, then Alice turn would be there. And then we count whose turn the last would be. If Alice plays the last turn, then Alice will get all the greater than 1. Otherwise, Bob gets all greater than 1. And now compare the scores here. Like, I think we need the count for the even one. See, it gets a W. Like, it says if n is even and n minus 1 count of 1 and the last number is also odd, then it's a draw. So like if you know the number of odds, number of ones, and then you can definitely count the number of evens, right? Because sum of all three of them is even here. So like the simplified condition it says Alice wins. If sum is odd, this is the condition for Alice. The condition for Bob is like n should be even and then number of ones should be equal to n minus 1. Like, does this holds true? Like, these should be the simplified condition you can arrive at. But the way to play this game would be like you first pick all the ones, and then whoever's turn is last will be able to get all the remaining coins on the pile there. So I will mostly leave it with my solution as well. I won't try to simplify it further. This condition, like that's where we would stick it. Count the number of odd, even, and one pile. Then first ones will be distributed equally. And whoever's last turn gets all the remaining points, which would be like sum of all the numbers is odd. Then Alice get all the even and odd piles. Otherwise, Bob gets all the even and odd piles. Now you compare the score. If score of both of them is equal, draw. If Alice score is higher, Alice wins. Otherwise, Bob wins. So like any questions or anything which I should try to repeat again. Like this was how I tried to solve it in the yeah. Like the main idea is like once there is no pile with one coin, the other person can just try to repeat the move of the other person, and whoever plays last would be the one mirroring the other person's move. So like if they pick something from a pile which contains even number of coins, you also pick from the same pile. Otherwise, whoever is playing the last will have a pile whenever someone picks from the odd pile. So they would pick it from the other pile which contains odd coins. So like any questions or anything before we try to move to the next problem? Because whoever is playing the last has an advantage that they can mirror the moves of the other player. So after removing the cases where the piles contain only one coins, the last player can mirror the moves to get all the coins of all the piles. Like we don't even need this odd one, etc. as well. Let's just say like make it simplified. Let's just say some plus plus. Like this odd even makes it a bit more problematic. We distributed odd, and if sum is odd, then Alice will get all the piles other than one. Like the ones are distributed equally. Otherwise, Bob is playing the last one, so Bob will get all the piles which contains more than one pile. And now you compare the score. Where n is equal. Okay, sum should be equal to current. Yeah, if you have a doubt in binary minimal, you can ask. Like, I will take it up before going to the next problem. Like, this is even simplified model. Count the ones, count the sum of all the numbers. Ones are distributed equally, one after the other. So if there are extra one after distributing equally, if extra one is there, Alice will get it. And now if sum of all the numbers is odd, then Alice would be the one who would be playing the last move. So she would get all the piles which contain more than one coin. Otherwise, Bob would be the one who would be playing the last one, and she will get all the other piles. and then you compare the score of all three and get the required number. So, like only condition to draw is last element other than 1 is even. Along with that, you also need that the number of n should also be even, something like that would be required. Like first case is if all the ones are there, then also everything is distributed equally if n is even, and like something like that, like you can try to figure out like condition. And like I will probably move to, okay, Tarun has asked for I equal to, like Tarun has pasted a quote, like although like it would have been better if you could paste your quotes link there, then, but yeah. Probably if I have to look some code, then you can probably join the Discord server there. You can also say, and we can have a back and forth chat to see if there are any bugs or anything. Because like it's really difficult to copy code from this small chat and try to see what's going on. So Manhattan's or is here. There is an n cross m grid. The rows are numbered 1 to n and from top to bottom, and columns are numbered from 1 to m from left to right. Alice is at coordinate x, y. Alice needs to calculate bitwise XOR of Manhattan distance of all the coordinates in the grid from the point x, y. Note that Manhattan distance between the points x1, y1 and x2, y2 is calculated as this absolute difference. And like for example, if this is the grid, then this is at distance 0, 1, 1, 1, 1, 2, 2, 2, 2. So overall the XOR of all the numbers would be 0 over here because there are 4 ones and 4 twos. And similarly, we can probably try to look at the other example. The way I did it was, like let's first draw the matrix here. Let's say this is x comma y. Like this is the row where the person is standing. This is the column where the person is standing. And like there can be more rows here, for example. Like this would definitely be like this. The first thing I did was, let's look at this matrix and try to find the XOR of Manhattan distance of all the points. And this matrix is equivalent to, like this length would be n minus x. This would be n minus y. And then you can rotate it by 90 degree to move this XOR to here. So like the Manhattan distance of all the points in this area would be equivalent to like taking a matrix with x comma y as 0 comma 0. This length is n minus y. This length is n minus x. And let's say we have some black box, we have some function to calculate this. Now let's also pick this rectangle. Like this length would again be n minus x, and this, wait, this would be, like this length would be x, this length would be y, this length would be n minus y, and this length is x. So we can try to find, like we can assume that 0 comma 0 is the position and we need an Manhattan distance of all the points in a rectangle of length x comma y to get everything over here. Because if you see, if you rotate it by 180 degree, this point moves to 0 comma 0. And now for this area, you can rotate it by 90 degree and try to find the answer for a rectangle which has one length as x and other length as n minus y. And let's say we have a function which takes a rectangle and gives us the XOR of Manhattan distance of all the points in that. And how to calculate that, we will come back to it later. Now we can also take this rectangle. We can rotate it by 90 degree. This length would be n minus x and this length would be y. And let's say our same function gives us that as well. And we can also do it here. This length would be n minus x, this length would be n minus y. So if we have a function which contains n comma m, cal XOR rectangle which takes n comma n and gives us Manhattan distance from 0 comma 0. And we can call this function 4 times to get XOR of all the points apart from, like, you see, like this is counted twice here. Like this has like this area is counted twice and this also counted twice, so we have to account for this part as well. To calculate the area for these rectangles as well. So like those 4 rectangles plus these 4 rectangles total, it calls to cal XOR n comma n, and we would be able to get our final answer. Now the question is, like, how do we calculate it for a rectangle? Or like, probably to simplify, the other approach is like first solve the subtask. X equal to 0 and y equal to 0. Like, let's try to solve this problem first and then we will try to solve the original problem. And to calculate this, like, let's say this length is n, this length is m. Then you can see, like, like Manhattan distance here varies from 0 to n minus 1. Manhattan distance here is from 1 to n. Manhattan distance in this row is from 1 to n plus 1. Manhattan distance here is from 1 to n plus 2, 4 to n plus 3, so on, until m minus 1 to n plus m. Like, these are the continuous ranges we have. Like, we are first solving for the subtask where a given x is equal to 0 and y equal to 0. So if we define prefix or, I has XOR of all the numbers from 0 to I. Like, prefix XOR I means like XOR of all the numbers between 0 to I. Then XOR rectangle n comma m would be count equal to p XOR m minus 1. First row, count slash equal to p or m into p or 0, which denotes like XOR of all the elements between 1 and m. Count second row, m plus 1, subtract p or 1. This denotes XOR of all the points from 2 to m plus 1. So on, count slash equal to p or n plus m, so p or m minus 1. This is m minus 1. Like this denotes XOR of all the points of distance n to n plus m. This is 0 to m minus 1. This is 1 to m. This is 2 to m plus 1, and so on. So we need, and like if you notice, had this been 1e5, we would have able to solve it by now. But because this is up to 1e9, we need some method to calculate this prefix or in order 1. And like this was the observation part over here. Like I brute force all the small values. And like let's just see like what is the prefix or of all the numbers from 0 to n. Problem code is MNXR. If you brute force prefix or for all the numbers, like the idea was to observe a pattern here. And you can say the number is 0, 1, 3, 0, 4, 1, 7, 0, 8, 1, 11, 0, 12, 1, 15, 0, 16, 1, 19, 0. And like you can now add conditions based on reminder modulo 4. Like for example, if 0, basically like 0, 4, 8, 12, 16, the prefix or is the same number. And whenever the reminder is 1, like the XOR becomes 1. Like for 1, 5, 9, 13, the prefix XOR is 1. And whenever the reminder with 4 is 2, then the XOR becomes plus 1. So here 3, for 2, the XOR is 3. For 6, the XOR is 7. For 10, the XOR is 11, and so on. So it pretty much changes to these 4 conditions here. If reminder modulo 4 is 3, then the prefix XOR is 0. Like this is. If reminder modulo 4 is 0, then the prefix XOR is n. Like I knew this a pattern like this would existed because I have seen it in one of the education round as well. So like that's how we can calculate prefix XOR in big O of 1. Now if we move back to our same solution, if we define one more thing, pref XOR as XOR of prefix XOR I for all the numbers from 1 to n. Like basically this is double prefix sum. First you find the prefix sum of all the numbers and then you take prefix sum again over here. Then you can notice that this algorithm we have written, this is if you take double prefix sum, then this is XOR of all the numbers from n minus 1 to n. And this part is prefix XOR, like prefix XOR of prefix XOR, which we already had double prefix XOR from all the numbers 0 to n minus 1. So if we can also somehow find the double prefix XOR in big O of 1, then we can also calculate like these two in order 1 as well. So like I define prefix XOR I as like double prefix XOR. Double prefix XOR I would be prefix XOR up to I and all the numbers before it. And the idea was if you try to print this over here, then you will also notice a pattern again. The problem was more about noticing patterns here. Like here now it's a pattern of mod 8 here, like 01226700. After this number next set repeats 8922 141500, 161722 222300, 242522 303200, and so on continues. This time we can even take like mod 8 and then we can try to form the cases by looking at the pattern here. And once you are able to calculate double prefix XOR, the XOR for the rectangle with assuming x comma y is this part. Like this is how those three conditions will turn out to be. Like this prefix XOR and everything over here. And once you know how to solve for x equal to 0, y equal to 0, what you can try to do is like you can make it a rectangle again. You can divide all the parts into 8 rectangles. These 4 denotes the rectangle which we got assuming x comma y as origin and rotating by 90, 180, 270, whichever we need. And these 4 are the 4 steps we have. And at last, whatever we get would be the final answer. Like, should I repeat anything again, or if something is not clear, I can try to take it again. Otherwise, like, this was probably the last problem, and I will call it a day. And like, probably if someone doesn't know why their code work, they can probably join the Discord server. There, I can take a look at the code once. Like, I generally check Discord server once in a day, and like, if there are some questions or anything, I try to answer them. Okay. Like, any ideas on operating on a, like, to be honest, I tried this problem for an hour or so. Like, I did not got any idea. And like, what I see is, like, one thing which I noticed was, like, some of numbers at odd index should be equal for both the arrays, and sum of numbers at even index should be equal for all the arrays. And what they probably need is, like, you will have to try to find some function which remains constant even after applying this operation. And so if you take it for the other, like, that was the idea I was trying. And what someone in the chat wrote was, like, there was some greedy idea over there to try to make the arrays equal. And like, one thing you can notice is that if you apply the operation 2 times on the index I, you get original array same. So in a sense, you can say, like, this is a revertible operation. So like, one way could be, like, you change A to some other array and B to some other array as well, and like, some greedy idea, or like, let's say you try to find the lexicographically minimum array you can get from A, and lexicographically minimum array you can get from B. And if both of them are equal, then you can say, like, the final array should also be equal, because the operation are reverts over here. And to get that would be like, okay, looks like the internet got disconnected once. Like, basically what I said was, I was trying some general ideas on this problem, and the way I did it was mostly, like, because the operation is revertible, if you apply operation 2 times on index I, you get the same array back. So one way was to try to get some lexicographically minimum or some lexicographically largest array from both A and B by applying these operations. And if that array is same, your answer is equal. Okay, someone in the chat says, make A equal to B by applying this operation such that AI equal to BI for all I from 1 to n. Like, that's what we need, but not really sure. And pretty much that was it. Like, any questions or any other questions or anything before I call it a day today? So if there are no questions, then thanks everyone for joining today. And I hope, like, the bucket game you were able to understand. Like, because I think I was a bit vague there and was not able to express myself correctly.